everyone, welcome back to the channel. If you're new here, don't forget to hit that subscribe button and ring the bell for more AI and NLP content. Today, we're diving into the foundation of every natural language processing project, text preprocessing. Think about it. Computers don't understand language the way we do. When we type machine learning is amazing versus machine learning is amazing, we see the same meaning, but computers see completely different strings of characters. That's where preprocessing comes in. We'll cover three essential techniques. First, tokenization, breaking text into bite-sized pieces. Second, stop word removal, filtering out the noise. And third, case normalization, making everything consistent. By the end of this video, you'll be able to transform messy, raw text into clean, structured data that's ready for any machine learning model. Let's jump right in. Before we dive into the techniques, let's understand why preprocessing is so critical. Imagine you're building a sentiment analysis model to analyze customer reviews. You collect data from Twitter, Amazon reviews, product forums, and what do you get? Text that looks like this. You've got random capitalization. This product is amazing! Triple exclamation mark. Punctuation everywhere. Great. Love it. ... Common words that don't add meaning. The, is, an. Emojis, hashtags, URLs, the list goes on. If you feed this directly into a model, it will treat amazing and amazing as two different words. That's a problem. Preprocessing solves this by reducing complexity, fewer unique words to process, improving accuracy, models focus on meaningful content, and speeding up training, less data to crunch. Now, let's see how each technique works. Let's start with tokenization, the very first step in any NLP pipeline. What is tokenization? Simply put, tokenization means breaking down text into smaller units, called tokens. These could be sentences, words, or even characters. Think of it like this. If text is a paragraph, tokenization is like breaking it into individual Lego blocks that you can analyze separately. Let me show you with a real example. Here's our input text. Artificial intelligence is transforming industries. Machine learning powers modern applications. Now, if we apply sentence tokenization, we get sentence 1, artificial intelligence is transforming industries. Sentence 2, machine learning powers modern applications. Great, but we can go deeper. If we apply word tokenization, we break it down even further. Artificial intelligence is transforming industries, machine learning powers modern applications. Now we have individual words, tokens, that algorithms can actually work with. You might be wondering, why bother tokenizing? 3 key reasons. Number 1, it simplifies analysis. Instead of looking at huge paragraphs, we focus on individual words or sentences. Number 2, it enables feature extraction. Want to count word frequency? Tokenize first. Want to convert words to embeddings? Tokenize first. And number 3, it's the foundation for everything else. Language models, text classification, machine translation, they all start with tokenization. All right, let's see this in action with Python code. We'll use NLTK, the Natural Language Toolkit, one of the most popular Python libraries for NLP. First, let's import our tools. Notice how sentence tokenization properly handles abbreviations like doctor and question marks. And word tokenization? It even separates punctuation marks as individual tokens. That exclamation mark becomes its own token. Now, here's something cool. NLTK isn't the only game in town. Depending on your use case, you might want word punctuator tokenizer, aggressively separates all punctuation. Regex tokenizer, use custom regex patterns for total control. Spacey, industrial strength, blazing fast for production systems. And for modern language models like BERT or GPT, they use subword tokenization, breaking words into smaller pieces like planging or unbreakable. This helps models understand word structure and handle rare words better. Okay, tokenization done. Let's move to the next step. Now let's talk about stop words, the filler words of language. What are stop words? They're extremely common words like the, is, and, a, in, on, at. These words appear constantly but carry very little meaning on their own. Let me show you the impact. Take this sentence. The cat is sitting on the mat. Looks normal, right? But from an NLP perspective, half these words are just noise. After removing stop words, cat, sitting, mat. Look at that. We went from 7 words to 3, and we still understand the core meaning. A cat is sitting on a mat. The essence is preserved, but the data set is 57% smaller. So why is this important? First, it reduces noise. Models focus on content words that actually matter. Second, it decreases processing time. Imagine analyzing 1,000,000 documents. Removing stop words can cut processing time by 30 to 40%. Third, it improves performance. For tasks like document similarity or keyword extraction, stop words just get in the way. Let me show you how to do this in Python. Here's the practical implementation. We'll use NLTK's built-in stop word list. Notice 3 important things. 1. We convert to lowercase first. This ensures proper matching. 2. We use list comprehension for efficient filtering. 3. Punctuation marks survive this filter. We'll handle those separately if needed. But here's a pro tip. Sometimes the default stop word list isn't enough. Maybe you're analyzing financial documents, and words like portfolio or investment appear so frequently they become stop words in your context. Or you're building a medical chatbot, and clinical terms need different treatment. You can easily customize the list. Add domain-specific words, remove words you want to keep, total flexibility. All right, one more technique to cover. Our final technique is case normalization, the simplest but absolutely essential step. Here's the problem. Computers treat machine, machine, and machine as 3 completely different words, but to us, they're identical. Case normalization fixes this by converting everything to lowercase. Simple, but incredibly powerful. Look at this example. Input, machine learning is powerful and exciting. After normalization, machine learning is powerful and exciting. Now every variant of these words will be treated consistently. This is especially important for sentiment analysis, text classification, keyword matching, and search functionality. Let me show you the code. It's literally 1 line. That's it. Just call lower on your text string. But remember, order matters. Always normalize case before removing stop words. Why? Because stop word lists are typically lowercase. If you try to match the against the, it won't work. So normalize first, then filter. Now let's put it all together into a complete pre-processing pipeline. Our workflow. Step 1, convert to lowercase, case normalization. Step 2, tokenize into words. Step 3, remove stop words. Step 4, optional, remove punctuation. Let's see the complete code. Here's a production-ready pre-processing function. Let's test it with a real sentence. Input. Artificial intelligence is shaping the future of technology. After pre-processing, artificial intelligence, shaping, future, technology. Beautiful, clean, normalized, and ready for modeling. You can wrap this in a function and reuse it across projects. So where does this actually get used? Search engines. Google tokenizes and indexes billions of web pages. When you search, your query gets pre-processed the same way for accurate matching. Chatbots, virtual assistants like Siri or Alexa, pre-process your speech-to-text input before understanding intent. Sentiment analysis. Amazon analyzes millions of product reviews. Pre-processing ensures great product and great product are treated identically. Content recommendation. Netflix, YouTube, Spotify all pre-process text descriptions to power their recommendation engines. Spam detection. Email filters tokenize and analyze message content to identify spam patterns. Every single NLP application starts here. Before we wrap up, here are my talk tips from real-world experience. Tip 1. Always lowercase before stop word removal. I've seen so many beginners miss this. Tip 2. Manually review your tokenized output on a sample. You'll catch edge cases and special characters. Tip 3. Consider lemmatization after tokenization. This reduces words to root forms, like running becomes run, better becomes good. And tip 5. Customize stop words for your domain. Legal documents, medical research, adjust accordingly. And tip 5, save your pre-processed data. Don't reprocess every time you train a model. Quick warning about common mistakes. Mistake 1, removing stop words for all tasks. Sometimes they matter. In not good versus good, that not is crucial for sentiment. Mistake 2, over-aggressive pre-processing. Don't remove so much that you lose meaning. And mistake 3, ignoring context. Email addresses, URLs, hashtags. Decide how to handle these before pre-processing. Learn from my mistakes. Save yourself the debugging headaches. And that's it. You now understand the 3 pillars of text pre-processing: tokenization, breaking text into analyzable units, stop word removal, filtering out the noise, and case normalization, ensuring consistency. These might seem simple, but they're the foundation of every NLP project, from basic text analysis to GPT-powered applications. In the next video, we'll level up with stemming and lemmatization, techniques that reduce words to their root forms for even better analysis. If you found this helpful, smash that like button. It really helps the algorithm show this to more learners. Subscribe for more NLP and AI tutorials and drop your questions in the comments. I read every single one and love answering them. Thanks for watching, and I'll see you in the next video.